Hello everyone. Welcome to this video about the Pythagorean theorem. This unit is all about right triangles and how we use them and how we use the Pythagorean theorem to tell us different things about a right triangle. So in a right triangle, the two adjacent sides to the right angle, or the angle that is 90 degrees, are known as the legs. The legs are called A and B, and they are also the shortest side of the um, right triangle. So let's just pretend I make that perfectly straight, and here we go, a right triangle. If I wanted to label the legs, I would say, okay, here's my right angle, and any side that is touching this right angle are legs. So here is leg 1, and we can call this one A. And here is leg 2. And we can call this B. Okay. Uh, the opposite side from the right angle, you see that little arrow? That's the opposite side. It's called the hypotenuse, or C. The hypotenuse is always going to be the longest side of a right triangle. So here we go. We draw a little arrow, and that's the hypotenuse. I'm just going to write hypot for short. So this is the long side. So long. So long to get there. These are the short sides. A and B are short, hypotenuse is long. Um, the Pythagorean theorem tells us how the side lengths of right triangles are related. In any right triangle, the square of the hypotenuse, this means that if you multiply C by itself, that's what a square is equal to the sums of the squares of the other two sides. This relationship can be represented by the equation a squared plus b squared equals c squared. So if I wanted to find this side, and I called it the long side is c, I would have to square my side length a, then add my side length b. Is it showing this? Okay, it is good. And this equals my side length c, or c squared. But there's a problem with this. This is not going to be telling us how long this side is. It's telling us how long this side is times itself. And so how do we deal with something that is squared? Easy. We just take the square root. So you're going to need a calculator for these ones. When you do the calculations, calculators will help immensely. And so if you do that, if you wanted to just find the side C, you would take the square root, and it becomes the square root of a squared plus b squared. This equals C. Now, for you math-brained people out there, you might realize that this has two answers. Remember, since we're looking for a distance of a triangle, distance is always positive, so your answer should always also be positive. We should not get any negative answers here. So we always look for the positive root of this equation. Now, good news is you don't have to memorize this formula. You just have to know how to use it. All right, so if you're looking for C, or the hypotenuse side of the triangle, and it's a right triangle, all you have to remember is a squared plus b squared equals c squared. And then whenever you add these two numbers up, take the square root of the result. So, and that my next oh, okay. That's going a little bit beyond what we're doing right this second, but let's take a look at this next part, okay? So label A, B, and C on each of the right triangles below. So remember, up here, A and B were known as legs, and C is the hypotenuse, or the long side. So let's label these together. So here's our right angle, and we know that A and B are always going to be right next to our right angle, or that's called adjacency. So A is going to be here, or you could also say A is here. Either one works. B is going to be here, because remember, they're both legs and they're both next to our right angle. These are touching that right angle, they're next to it. And then, if you want, you can draw the arrow diagonal from the right angle, and you're like, oh wait, it touches something. This must be our hypotenuse. So this is going to be side C. We'll do a couple more together, and then I'll let you do the other two on your own. So first identify your right angle. Oh, there it is. There's a little square. Here's my A. And then here's my B, because these are the short sides. Now, even though this looks like a long side, remember, it's the hypotenuse that's always the longest side. And here's my C, because it's going to be across from my right angle. Try the next two on your own, and then when you're ready, continue onward to the next part. You can pause the video and join me again when you're finished. All right. Use the steps below to find the missing side lengths of the right triangle in example 1. So first, we want to label our sides. So we want to label A. Hold on. We're going to want to label B. And I wish they put it in the right place, but that's okay. We will work around it. And we are also going to want to label C. So our legs and our hypotenuse. Substitute the known values into the theorem. A squared plus B squared equals C squared. So you'll, like I said, you can use one of the star formula sheets I have in the back of the room if you get stuck on this part. Solve for the missing variable by taking the square root of both sides. So we just solve for the missing variable. So let's take a look at example 1 and see how this applies. So I don't want you to worry about the square root part until the very, very end. Just do a squared plus b squared first, then worry about taking the square root of that afterwards. So first, we'd say, okay, identify my sides. I've got A, B, and C. Perfect. I know what my A, my B, and my C are. Then I plug in my A, B, and C into my formula. A squared plus B squared equals C squared. All right, now I simplify. What is 3? Remember what squared means. So squared does not mean 3 times 2. It means 3 times itself, that many times. So this is 3 times 3 plus 4 times 4 equals C times C. Now that we have that, remember, I'm not even going to worry about the C until the very end. I'm going to say 3 times 3 is 9, plus 4 times 4 is 16, equals C times C. So then I solve. Well, what is 9 plus 16? You all should know this. You've been doing this since grade school. It's 25, right? So 25 equals a number times the same number. So what times itself is 25? Well, this is where your calculator might come in handy. So you can either figure out this little riddle, or you can take the square root of each side and say, okay, the square root, this is where I'll switch back to here, because it's easier to write square root here. So you could say the square root of 25 equals C. So 5 would be your answer. And look at that. It follows the same principle that we talked about earlier. Your legs are your shorter sides, 3 and 4, and your C is your longer side, 5. All right, so let's see. Let's do one more together, and then I'll show you what happens. Okay, this video is getting kind of long. It's okay. I might split it up into 2 parts. Anyway, we'll do one more together, and then I'll show you what happens if you need to solve for a leg instead of a hypotenuse and how that would change the problem. So this is first we identify our A, B, and C, so our legs and our hypotenuse. So first I'd say, okay, here's a leg, so that's going to be A. Here's another leg, so this is going to be B. And my C value is the hypotenuse. So remember, our hypotenuse is always directly diagonal to our right angle. And our legs are always going to be touching that right angle. So leg, leg. We're going to square them next, following our formula. So 24 times itself plus 7 times itself equals C times itself. So 24 times 24, that would be 6, and then 16, that would be 8 and 8. 8 plus 8 is 16, and that would be 2 times 2 is 4, 5. There you have it. That's what 24 times 24 is. And I'll just double check. just to be safe. Oh, I got it wrong. I forgot to carry the 1. It's 576. See, that's what happens if you don't double check yourself. All right, so 576 equals C times C. Now I can use my calculator. Does it show my calculator? Oh no, let me check. No, it doesn't. Okay. And I could say, okay, 576, take the square root of that. Oh, okay, I made a mistake. 24 times 24 is 576. I did not add 7 times 7 in yet, so this becomes 576 plus 49. And that's what a calculator does. It helps you check mistakes. We all make mistakes. We're all human. It's okay. So 576 plus 49. Put that in. And you get 625. Equals, remember, it's not, that doesn't equal C. It equals C times C, or C squared. So then, to figure out what your C is, all you have to do is take the square root. So we say, okay, the square root of 625, put it in our calculator, and that comes out to be 25. I keep opening up that tab by mistake. So C equals 25. Because 25 times 25 is 625. I'll put the work over here. And I'm going to move that B value so you can see what is A and what is B. Hopefully this lets you see what is happening a little bit easier. There we go. This video is going on a little bit long, so let's do one more and then we will, I'll let you guys to it. So what happens if you have a hypotenuse that's known, but a leg that's not? We haven't run into that situation before. So we're still going to follow our basic principle. A times A plus B times B equals. All right. First we identify A, B, and C. So remember, A is always going to be adjacent. B is always going to be adjacent to our right angle. Sorry guys, I'm just a little flustered for almost starting a fire. Oh. C is always going to be opposite. That means the opposite direction, the opposite side of where our right angle starts. And B is always going to be adjacent. So in this situation, we have A and C, but we do not have B. So remember what I said? Don't even worry about B until the very end. So go ahead and plug in your numbers first. So first, you're going to plug in what A is. A is 16. We don't know what B is, and C is 24. Okay. Then we're going to calculate what those numbers actually are. So 16 times 16, 256. You could plug it in your calculator to check. Remember, it's always okay. Plus b times itself. We don't know what that is yet. That's fine. Equals 24 times 24. If you have a good memory, you remember it's 576. If you don't, just use a calculator. And then we think back to our two-step equations. We're like, huh, interesting. I've got a cat on this side, and I've also got a cat on this side, but my cats and bats are together. How do I get them on the same side again? Oh yeah, just take them away. Take them away from each side. So I would say, okay, I'm going to subtract 256 from here, and then I'm going to subtract 256 from here, combining like terms. Very, very important. That's why I tried to stress, hey, it's going to come back. Please learn this. So what we're left with is b times b, not b8, equals 576 minus 256. So it's going to give us 320. And then we use our calculator to take the square root. And did I do that right? 576 minus 256. Yeah, 320, okay. Then after you take the square root, just like you did it before, when you take the square root of 320, you get roughly, I say roughly because this is a big number, or a long number, I should say, 17.88, or you can say 17.9, or 89, sorry. And while I averted burning down my house, we also solved the mystery of how long the missing side was. Thank you for joining me on this. Your task will be to finish the Blackboard assignment, and it's going to include word problems, so be ready for that. Good luck. Don't let me down.